My name's Patrick White. I'm an Associate Professor in the School of Applied Sciences, and I'm also a member of Edinburgh Napier University's Centre for Conservation and Restoration Science. So a lot of my research is focused around camera traps. Now, ecologists use lots of different types of technologies, and one of the types of technologies that they've been using a lot in recent decades has been camera traps. Now, these are small remote cameras that we can put out to study the behaviour or the presence or the population size of different species. So they're motion detectors, and they have a similar motion detector to what you might have on your burglar alarm at home. So they detect an animal, and ideally they'll turn on. So in theory they should work well, but there's lots of different reasons why they might miss a species. So for example, if an animal is far away, they're more likely to miss the animal. If the animal is small, they're more likely to miss it. If the animal is a similar temperature to the background, so for example, if it's a semi-aquatic animal like an otter or a beaver, it's less likely to trigger. So one of the things that researchers do is try to find ways that we can use these effectively for a wide range of different types of animals. There's a big research need for institutions like Edinburgh Napier University to work with external partners, whether those are NGOs or ecological consultants or other types of organisation, to try and find the best way to use camera traps to protect biodiversity. One of the things we're doing is developing evidence-based approaches to camera trap otters so that ecological consultants can identify their dens, their resting sites, their breeding sites, and properly protect them from development or disturbance. We're also working with a charity in Panama called Conservation Through Research, Education and Action. And there we're working with this organisation to look at how we can use camera traps to study rainforest biodiversity. Now, camera traps are traditionally put on the ground because it's easy to do, but we're testing approaches to putting camera traps up in the trees. We're also doing some work with Wildlands Conservancy in Pennsylvania in the United States, and they're looking at how they can use camera traps to study weasels. Weasels are typically a very difficult species to camera trap because they're very small and they're very fast. So we're looking at testing different types of baits and lures so that we can make sure that if they're in the vicinity of a camera trap, that they come and investigate, and we can get pictures and identify species and work out where they are and where they aren't. Groups that we work with quite a lot are engineers and computer scientists. So ecologists are good at trying to use novel technologies to try and better understand and protect biodiversity. So we work with camera traps, but we're also working with drone technology, and we're also working with things called passive acoustic monitoring, which is where we use sound recorders to try and study biodiversity. And that can be terrestrial, so listening to bird calls and bat calls, or it can be marine, listening to underwater sound and underwater noise. One of the things I really value about working in the School of Applied Sciences and the Centre for Conservation and Restoration Science is the interdisciplinary nature of the research. So I think we're really good at working with external partners, consultancy, charities, other institutions, but also within the university. We try and work across the different disciplines. Working together, then we can really kind of innovate in terms of the approaches to protection of biodiversity.